Hi everyone, welcome to TLMS 2024. My name is Vicky and it's my pleasure to introduce our speaker today. Today we have Dr. Reem Al-Halimi. Dr. Reem Al-Halimi is the AI Enterprise Architect at Navblue, an Airbus company. Through her role, she is responsible for re-envisioning flight operations products into smart products, making users' workflow more efficient and their decision more effective. Dr. Al-Halimi received her PhD in computer science from the University of Waterloo in 2002. Since then, she has worked on a variety of machine learning projects that span many ML areas, including generative AI, computer vision, natural language processing, anomaly detection, and predictive models. Ladies and gentlemen, please join me and welcome Dr. Al-Halimi.
Hello, everyone. Good afternoon. So thank you for coming today. Thank you for joining us. My name is Reem Al-Halimi, and today I'll be talking about data in aviation. I'll talk about the complexity and demonstrate the complexity and richness of that data. I'll show you a couple of ways how you yourselves can explore and experiment with that data. And then we'll talk about challenges that we face when we try to pivot a company that is already established in an established industry like aviation into a data company, and what you can do to make it work. So to start, so you have an idea of the context of where I'm coming from, let's talk briefly about Navblue. Navblue is a flight operations software provider. So we provide software for commercial airlines that is related to the different stages of flight operations, meaning before a flight, you need to plan a flight. You have crew management. During a flight, you need to track it. You need to be planning it. You need to be monitoring it and communicating with the pilot. And then afterwards, that's post-ops, you can benefit from analyzing it for various reasons, including safety. And we also provide consulting services for things like optimizing the airspace. So that, for example, around an airport, what is the best way to have aircrafts come in and depart? And my role at Navblue as an enterprise architect data scientist is to recognize the machine learning opportunities that can enhance customers' experience based on business value. So I work with business owners or business value owners to translate machine learning opportunities into technical problems, machine learning problems, and then I work with the technical side, which is solutions architects and developers, to create the kind of feature that we can deploy to enhance our customers' experience. Okay. So we'll skip that slide. Basically, that slide was a small video. That slide was a small video of a flight from Toronto to Paris. So imagine that kind of experience, that kind of flight. What sources of data can you think of on that flight? Weather. Yeah. Temperature. Right? Air pressure. Speed. GPS data. What about the airports that you are leaving from and going to? Traffic patterns. The airports themselves are very rich in data. And then there is the aircraft itself. The aircraft is a very rich source of data. So you're right, there are the airports, there's the weather, including temperature, wind, pressure, There's speed, which is basically the part of the data that you can get from the aircraft. And then there's even the route itself. Which parts of the airspace did you go through to reach that route, to reach your destination? That's only a drop in the data space, in the data ecosystem for aviation. But we don't have a lot of time. We can spend a whole week talking about the different resources and data sources. Let's focus on the airplane. So the airplane itself, as a machine, the airplane is full of sensors. Over 3,000 sensors are in an airplane. So from those, you get things like measurements related to the engine, for example, the temperature inside the engine, the oil temperature, the pressure. You get things like measurements of the fuel. All of these are very useful for safety and other things, as I will show later. Then you have rotational speed of the engine, for example. You also have sensors related to the moving parts. For example, the flaps, the aileron, which are both on the wing, the angles at which they are at, and then what's on the tail, the rudder, the slats. You also have sensors outside the airplane so that it can measure certain parameters that it passes through. Things like, are there icy conditions? What's the air pressure? What's the airspeed of the airplane? And at what angle is that aircraft flying? Because that angle is very important in determining the state of the plane, given what we think it should be doing. Then there are things inside the airplane, like the communications, for example, between the pilot and the co-pilot, between the crew and ground, ATC, which is traffic control, airport traffic control. We have, which doors are closed, which doors are open, aircraft electrical current measurements. As I said, lots and lots of different data. So what do we do with that data? What do you think happens? So we have those during a flight. You're always measuring those, and a pilot is always measuring those, and they get alerts when things don't go right. But that's not where it stops. The first thing that happens is the airplane is a chatterbox. So it starts talking to airplanes around it. It tells them where it is, geospatial information. There's identification information about it. And it also shares that information with ADS-B receivers, which are receivers that are meant to receive that kind of information so that we can locate the airplane. And that can happen the receiver can either be on the ground or it can be in space. Why the aircraft needs to communicate its information to other surrounding aircrafts, I'll let you think about that. You can ask later if you want. For the ground base ADS-B receivers, there are those that are large ones near airports, but then the highest number of such receivers are actually smaller ones that are all over the Earth. Tens of thousands of them, and I'll show you how small. But it's those receivers, plus the space ones, that allow tracking services to show you, if you search tracking service, right now, you can see aircrafts that are airborne, live, moving in space to their direct destination. And it's that kind of thing that allows these services to show you this map. But you don't need to rely on this map, or you can actually rely on it and contribute to it, because project number 1. you can actually build your own ADS-B receiver. All you need is something like a Raspberry Pi and a USB dongle that can receive data from an antenna and an antenna. You put your antenna where there is no obstruction, and you put software on your Raspberry Pi that can decode and translate that information. And there is also open source software where you can do that. You can see that screen that I showed you before for your area. Or you can contribute by getting one of those for a service, and then you do the same thing, but then your data gets transferred to their networks, and then you see the screen that I showed you before. So that's something you can do yourselves. I think you can also do it with a phone, but I haven't, I'm not 100% sure. What else do you think we do with that data? All of that data, the voice data, the engine data, the angles and flaps, yeah.
Feed to the airport for turn management?
Sorry?
Feed to the airport for turn management?
Yeah, so you transmit it to the airport, or after, you mean after the flight, or during?
You know what's coming in and when it might need to be fixed, like for turn management of like fixing the aircraft.
Oh, okay, yes. And for that, you need to record it. You're right. There are several different types of recorders on the airplane. I'm only showing two here. One of them is the black box. Which one is it? Of course. It's the orange one. When do you think they became orange? From the beginning, they were not black. Black boxes are actually called like that because they used to use photo-based technology, and so the box needed to be completely dark from the inside. It was a French engineer that invented them. Okay, so that's a black box. And on the black box, you need to store, it's required to have a black box, it's required to store specific parameters. Airlines cannot change that. Then there is something else called a quick access recorder, which you can see here. On that, you can store whatever you want. 3,000 parameters in the more recent airplanes, some of them. So, and you can see here, that's what that data looks like. Actually, it's binary. And it's divided into subframes and then to words. And then that data is actually, after the flight, that data is transmitted either through Wi-Fi, connected or otherwise, transmitted to ground, and then it's used. So what do you use it for? Like you said, maintenance is one of them. Actually, one of the things that are done with a specific recorder is to get the aircraft check the aircraft's health after it arrives, before it leaves. But the other thing with the QAR, it's actually an amazing amount of data. So many different things. It kind of gives you an eye into what's happening with the aircraft at any moment in the flight without actually having a video. It's like having a video. So let's say you take these parameters out of your the QAR data. You have the acceleration, vertical, acceleration, horizontal, your ground speed, and your altitude. What does that tell you? That actually is data of an airplane landing. And this is from a paper that is trying to see when exactly touchdown takes place. And that's an example of how you can see what's happening with the airplane. There's a lot more that you can use to determine this and to even study the technique of a pilot, for example, when they're landing. And that's used to make sure that the pilots are nailing the way they should be landing. If training is need for training is detected, that data is used to help identify that as well. It's also used to help identify safety events where things are not bad yet, but there is an indication something went wrong. This time we were lucky. Next time we have to make sure that thing doesn't happen again. So it's extremely valuable. And what's interesting is you can actually try it out yourself. Try to see it, not with the airplane sensor. But you can use your own phone's sensors. There are apps that allow you to measure the acceleration of your phone, along with a lot of other things, which is extremely cool. You can look it up. And one user on Reddit tried that while he was landing, his flight was landing, and this is what he saw. So you can see the difference in acceleration when the aircraft was landing, when it was taxiing, meaning moving out of the gate, heading towards, getting ready to depart, and then waiting on the runway, and then taking off, and then climbing and turning. And then, again, he did it when they were landing, and you can see turning, approaching runway, landing, and taxiing, until the end when it's slowing down. So you can do it yourself. You can try it the next time you fly. And like I said, that's only a drop in the complex universe of data in aviation. And each and of itself, each one is useful. For airports, you have lots of things. We have airport charts. We have conditions of runways. We have runway specifications. You have the air traffic control and its communication, the communication itself with the pilot. And then you have the control center for the airline and their communication continuous with the pilot. Then you also have messages that are always going out about airspace conditions, restrictions, new updates about certain airports. So one of those types of communications is called NOTAMs, which is notices to airmen. And this is a screenshot from the FAA, which is the Aviation Authority in the US. You can go there and you can look for NOTAMs related to whatever you're interested in. The text of those NOTAMs has valuable information about things like, oh, this area in the airspace is restricted because of military activity, for example, or because of dangers for whatever reason. And you can imagine why that is essential to be able to identify that. And then when you combine all of these, you get an even richer set of information. You can do more with it. But it's not that easy. Aviation is an established industry, which means that you will find a lot of different technologies that were adopted over time with different, each has its own challenges. So technological challenges is one of the main challenges that you would face trying to pivot an organization within the aviation industry into a data company. You can have data that is on different servers, local, that is hard to access, that is stored in ways that are difficult to be of use for you, for your purposes. The infrastructure itself is disconnected. And because storage was expensive, you will find that a lot of that data, of which you need years if you're going to use machine learning, is deleted regularly, every 3 months, every 9 months, regularly. And so it's kind of like throwing out treasure. Then there are the challenges that come with the fact that it's an older technology, which is point number 3, which are legal challenges. Because In the past, data was just, the thing that they need to store to manage their operations. Now we're learning we can do something with that data. And so you have to have an agreement with your client that takes that into account. That if that is not taken into account, you could have, if that's not provisioned, then you would end up with valuable data that is sitting there that can be used to improve your services, but you can't touch it because that's not provisioned. So legal challenges from old way of thinking about data to more modern ways of thinking about data. Always safety, privacy, security, that doesn't change. And then there is number 2, which is regulations and data sovereignty challenges. And so data sovereignty is the right of a country, for example, to say the data that's produced within my country does not leave my country. That creates a lot of issues for you trying to combine it, for example, or use it for other things. There are also regulations, for example, with data privacy that says if a country doesn't have the same level of data privacy standards that I do, your data cannot pass through that country. So you have those kinds of privacy, those kind of regulations, plus things like Data Privacy Act and regulations that are now coming up more and more in Canada, Quebec, Europe, and the United States. All are important, very essential, but you have to be very aware of what those are so that you can do what so you can extract that data, but extract it in a proper way with respect to compliance and export control regulations and any other privacy regulations. And then there is the fact that this is all new. People are used to doing things in a specific way. So when you now tell them, oh, this can go better if you were to use this kind of feature or you change your workflow that way, not everyone's going to be welcoming that initially. People resist change. But on the other side of it, how can we provide or detect value that is useful for our customers? Because the fact that you can do it or you can build it doesn't mean it's useful. And how you introduce it also impacts how useful it is. I've heard someone say, well, they gave us delay predictions. What am I supposed to do with that? So flight delay predictions. So it's possible and easy to do flight delay predictions, but then how do you embed it in a way that is meaningful to your customer that does not impede an already very busy workflow? And then machine learning is a disruptive technology. You need to be able to embed a new way of working and thinking in something that is already established. So your organizational structure itself may not initially be conducive of machine learning. So you need to be mindful of that. You need to create the infrastructure, add the workflow within your organization that allows you to introduce machine learning in a way that gives value, but efficiently without extra unnecessary costs. So how do you make it work? Number 1, most important, you have to have buy-in from top leadership. As I said, this is disruptive technology. If the company is too busy trying to solve current problems, you will need top leadership commitment to help you move alongside that, because both are important. 2, you need to start with a data strategy and vision that aligns everyone, all stakeholders. It's like being on a boat. You start with an agreement of where you want to go. And then, when everyone is in agreement, that will help you build things together and will help you make better decisions. Then you need to decide how you will make those decisions, how you want to collaborate. What you need is something that ties in business, because they are the ones that are out there, business and sales, and they can see what customers are saying, they can see what the market is looking like and what is needed. From that, you can see where potential value is. Then you need to work with the technical people to translate that into actual features that work. Not everything that has value is machine learning. Not everything that can be done with machine learning is worth doing. It could be expensive, it could be risky, it could be not yet there in terms of technology. Researchers don't know how to do it yet. So you need to be able to do that and to collaborate. And finally, you need to be agile. Start small, learn from that, and build on it. And we need to know that from the get-go, there is no certainty in machine learning. You will know when you try it. So that doesn't mean that it's okay to keep adding costs. So you have to be mindful of costs, but also efficient and effective. And that's it.
Any questions? Well, I love seeing the black box is actually orange. I was chuckling in the back. All right, well, thank you so much.
Thank you.